welcome back to New As Science Practicals. Today we're looking at a chemistry practical on making salts. So our aims of today's lesson is that we're going to be adding an acid and a base together to make a salt, and also by the end of this video we're going to be able to write word equations for that reaction. So I'm going to just go to the visualizer and we're going to have a look at the worksheet that you should have open. So set as an assignment for your lesson today, you should have this worksheet open. It's called 6.1.6 Practical Sheet for Making Salts. So we've got a little bit at the beginning about setting the scene. So it's telling us what we're going to be doing today. So we're going to be looking at the reaction between an acid and a base and what that makes. So that makes a salt. Okay, and then we've got the aims that we've just spoke about and some safety. So I've got my hair up today because we're using a Bunsen burner, and I'll be putting some safety goggles on. So the first thing that I want you to do is to make a prediction. So remember, a prediction is what we do before we start the practical, and it's what we think might happen. So it says you are reacting sodium hydroxide, so that's one of our reactants, which is a base, with hydrochloric acid, so that's our acid. So we're adding our base, which is sodium hydroxide, to our acid, and I want you to predict what our products might be, okay? So pause the video here, have a go at that, and then we can come back to this at the end of the video and see if you were correct. Okay, so hopefully you've made your prediction now. So if we have a look at the method that we have, these are the steps I'm going to take. So we're going to add 10 centimetre cubed of hydrochloric acid into our beaker. Then we're going to add 10 centimetre cubed of sodium hydroxide. Okay, we're going to add those two together. We're going to give it a good stir and check the pH. Okay, then we're going to add that into our evaporating basin and leave it to evaporate. Okay, we're only going to leave it to evaporate until about half of the liquid has evaporated, so that then we make some nice salt crystals that I'll be able to show you later. So I'm going to take this over with me. Okay, so at this point I'm going to put my goggles on. So step one of my method was to measure out 10 centimetre cubed of hydrochloric acid. So I've got my hydrochloric acid here. Now I'm going to use a pipette to do this because my measuring cylinder is quite thin. So while I'm doing this, I want you to have a think, what might the pH be of hydrochloric acid? Okay, don't worry if you can't think of an exact number, but what might the range be that we looked at last week? Also have a think, what colour would this go if I added universal indicator into there? Okay, so checking at eye level, I've got exactly 10 centimetre cubed, so that's perfect. So I'm now going to add this into my beaker. So I've got an empty beaker here. So I'm going to add 10 centimetre cubed of hydrochloric acid. Okay, I'm now going to give this a rinse. Okay, so I've got my clean measuring cylinder now. Now step four was to add 10 centimetre cubed of sodium hydroxide. So I've got my sodium hydroxide here. So I'm going to use a pipette again to measure out 10 centimetre cubed of that. Again, have a think. Sodium hydroxide, is that an acid or a base? Okay, what pH might that have? And what colour will it go with universal indicator? So hopefully already on your worksheet, you will have written your prediction. So in the theory lesson that you did earlier in the week, hopefully you found out that when you add an acid and a base together, you make salt and water. So if you wrote salt and water for your prediction, then that's fantastic. But if you can go a step further and actually try to name that salt, then that is absolutely amazing. So I've got my 10 centimetre cubed of sodium hydroxide. I'm going to add that in with my acid that's already in the beaker. Okay, then I'm going to give that a good stir using my glass rod. And then what I need to do is test the pH of this. Now, just quickly have a think about what pH might this be. If I've added an equal amount of the same concentration of acid and base. Okay, so have a quick think about what the pH might be. Now, I'm going to be using universal indicator paper for this one, okay? So often in the lessons that we've been looking at so far, we've actually added drops of universal indicator into our solution, whereas today we're using universal indicator paper, okay? And this is yellow paper. We just add a quick drop on and it changes colour just like universal indicator does. So I'm just going to take a drop from my solution. And what you will see is if I hold that up to the camera, what you will see is that's gone green, okay? So you can see it's a nice green colour, showing that it's about a pH of 7. Now that is what I would have predicted, that it will be a pH of 7, because we've added an acid and an alkali together, okay? Remember, when we add an acid that would usually have a pH of 0 to 6, and our alkali that has a pH of 8 to 14, so if we're mixing those together, we would expect it to go in the middle of a pH of 7, which is exactly what we've got, okay? So now what I need to do is I need to pipette about 5 centimetres cubed of my solution into my evaporating basin. So I'm just going to do that now. Okay, so I've added about 5 centimetres cubed into my evaporating basin. And what I do now is I heat that up. Okay, so I'm going to heat that up and speed up the reaction. So as I'm heating that up, I'm going to form 2 products. So make sure you've had a think about what those 2 products would be based on your lesson last week. So we're reacting an acid and a base together. So I'm going to put my Bunsen burner onto a hot blue flame. There we are. And I'm going to start heating up my solution. Now I'm going to only heat it up until about half of the liquid has evaporated. Because if I evaporate it all, then I won't make very nice salt crystals. So I'm going to evaporate until there's a few drops left. Okay, I've not got much in there anyway. And I'll bring the phone a bit closer so that you can see what actually happens in a moment. So this will probably take a few minutes for me to do this. While I'm doing this, really try and test yourself to name the salt that's being formed. Okay, we've got sodium hydroxide and hydrochloric acid. And then think about what the other product will be. Okay, so we're reacting an acid with a base. So hopefully from your first lesson on the theory of making salts, you will remember that when we react an acid and a base together, we make a salt and water. Now obviously, because we're heating up this evaporating basin, the water will just evaporate, okay? It'll go into a gas and it will just evaporate. So we're not going to see any water. So what we're doing, the reason we're heating this up is to get the water to evaporate faster, so that we're just left with our salt. Okay, we're nearly there. I'm just going to leave it a little bit longer. I'll hold the phone over in a moment so you can see. So you can see some, what I can see right now is some salt being formed around the edge of the liquid. Okie dokie. So I'm just going to grab the phone so you can see that a bit better. So if I hold that over, what you can see is we've made a nice amount of salt there, okay? So you can see we've got that white salt and all of our solution has now evaporated. So all that water, which is the other product we form, has evaporated and we've just been left with our salt, okay? And remember, our salt is going to be made by our hydrochloric acid and our sodium hydroxide. So hopefully by now you've predicted the name of that salt and come to the conclusion that it will be sodium chloride, okay? Sodium chloride is the name of our salt and our other product is water. Okay, so we will carry on trying the worksheet now. So we we are going to go on to the rest of the worksheet now. So what we can see is we've got our results table, so I want you to fill this in. So our first row is observations before the solution was heated. So you could write in here it's a colourless solution. Once I added my acid and alkali together, it was colourless, so a colourless solution. Observations after the solution was heated is we've got our white salt. Now I want you to pause the video, and for about 5 or 10 minutes I want you to try the questions that follow on from our results table. So we've got questions 1 to 5. If you finish questions 1 to 5 nicely and before the time is up, then you can go on to the extension questions. Okay, so pause the video here and then we'll go through them. Okay, so state the names of the two reactants used. So they're the two things we mixed together at the beginning of the video. So we added hydrochloric acid to our sodium hydroxide. Okay, so they were our two reactants. Name the two products that were formed. Okay, generically we formed a salt and water. Okay, however we now know the name of our salt, and it's called sodium chloride. Okay, because remember we take the sodium, the metal, from our base, sodium, and we get the end of our salt name from our acid. So if I had hydrochloric acid, it goes to chloride. If I had nitric acid, it would be nitrate. If it was sulfuric acid, it would be sulfate. Write the word equation. So we're going to write out our reactants. Hydrochloric acid plus sodium hydroxide. Then remember we draw an arrow to show that our reaction has happened. And our products were our sodium chloride and water. State the pH of the solution in your beaker. So remember when we added that, we got a pH of 7 because it went green. Okay, our universal indicator went green, showing a pH of 7. And the reason of this is because we've added an equal amount of acid and base. And also they had the same concentration. Okay? So self-assess your answers for questions 1 to 4. If you need to pause the video here, then please do. Okay, and then question 5 says, what does this tell you about the final solution? So our final solution, remember, was pH 7, had that green colour, so it's neutral. Okay, and this is because we've added our acid to our base. Now this is called a neutralization reaction. Okay, neutralization reaction. So hopefully you remember that from a few lessons ago. When you add an acid to a base, it's called a neutralization reaction. So we form our salt and our water. Remember, water has a pH of 7. Now, if you've only got up to this point, that's absolutely fantastic. But if you have some time left, then pause the video and try the extension questions. Okay, so the extension question says salt can be formed when metals react with acids. Predict the name of the salt that is formed when magnesium reacts with hydrochloric acid. So this time we're reacting a metal, magnesium, with hydrochloric acid, whereas the other example that we've done so far has been an acid plus a base. So this time we're going to form a different product. So we're going to form magnesium chloride as our salt, but instead of forming water, we would form hydrogen. So it's going to be magnesium plus hydrochloric acid goes to magnesium chloride plus hydrogen, because this time we have a different reaction because we're just starting with our metal, not a metal hydroxide like we did in our experiment. Okay, so please make sure you self-assessed all of your answers. Okay, you've got that whole practical worksheet complete. So hopefully you've enjoyed that lesson today. I think we've hit our aims, so we know now what happens when we add an acid to a base. Okay, we form salt and water. And if you got onto that extension question, then we also have been able to write an equation for what happens when you add an acid to a metal. So you form a salt and hydrogen. So hopefully you found that lesson useful. If you need to rewatch any of the video, then please feel free to do so. And we will see you next week for another chemistry video.